Okay, so once again, you're going to need 4 different colors, just like last time, and we're going to talk, we have already kind of done a little bit of an exploration and talked about kind of these different numbers and changes they make. So I'm going to give you the basics for any transformation for a linear function. Now, this can get much more complicated and detailed than this, and you'll see a bigger, I guess, kind of a formula for transformations when we get into quadratics and absolute value and things like that. But for linear, we can keep it kind of basic because a line itself is pretty basic. So, so there's just a few key points here, and what you noticed here is instead of mx plus b, I've changed it out to ax plus k. When we deal with transformations, we talk about a being kind of that slope or that rate of change, and then k is actually going to be our in this case, y-intercept. So we get those very similar to what we're doing already with mx plus b, but we're using 2 different variables to represent those pieces of the puzzle. Because when we deal with transformations, it gets a little bit more complicated in some of the other types of functions, and so we use h and k actually to represent those. And so we want to keep that continuous moving even from linear, which are more basic, into the more complicated ones. So I want to go ahead and get you used to seeing the a and the k values at least, so that when we add in extra pieces of the puzzle, it won't be so complicated. Okay, so here's kind of the basics of what you hopefully noticed. When we put a negative in front of the a, it represents a reflection across the x-axis. So reflection is a key word here. It may be important for you to highlight that. That's a type of transformation that happens, and what that is it allows us to basically, it switches the slope of the line from positive to negative. It's a flip across the x-axis, but with a line it looks a little bit different, and so it's actually going to change the slope of the line and make it negative, moving in a downward into the right direction. Now over here in the next part, we have the absolute value of a. So that value itself from that first example that we did over here, so we noticed here that when we flipped those, it changed the direction. But then over here, we noticed that the absolute value of this number, whether it's 2 or negative 2, the 2 portion of it tells us how steep that line is going to be. Same thing down here, 3 and negative 3 were the same steepness, okay? They were just going in opposite directions. So the negative is what changed the direction. The number itself is what changes the steepness. 2, 1, 1/2, and 4, and you can see how each of those changes that steepness. So absolute value is the absolute value of a is what represents the steepness of the line when we deal with a linear function. Now, when we deal with any other type of function, what we call this is a vertical stretch if the number is greater than 1. So you'll notice like 2 and 4 got much more steep, okay? So that became a vertical stretch. And what you think about that is if you grabbed the 2 end points of that line and you stretch them up and down vertically, it's going to get a much more steep line, okay? So just kind of, you have to imagine that. Now, if it's between 0 and 1, okay, if the absolute value is between 0 and 1, it represents a vertical shrink, or we actually call this later on a vertical compression. And I'm going to go ahead and write compression on there because that's the more common term, a vertical shrink or a vertical compression. Okay, and so that means that the slope of the line becomes more gradual. It's like taking the 2 endpoints and shoving them down, and what happens is the harder that you push them, the more compressed they get, and so they get more gradual with that line. It's not quite as steep. Okay, so those are the kind of the 2 major changes we noticed so far. Then on the back of that exploration that we did, we noticed that if we leave our slope alone, but we change this y-intercept, or in this case this k value, it moves our line up and down the y-axis. Okay, and so what it happens in more technical terms is that k represents the vertical translation, meaning its movement or its sliding up and down. So if k is positive, it's going to move it up the origin, which we know that because if a line goes through the origin, it has a y-intercept of 0, but if it has a y-intercept of 4, it moves up. Same thing here, negative k is translated down from the origin, so it's going to move down. Okay, and so With your 4 colors, again, let's just go ahead and talk this through. We're going to start with this first one, line y equals x. So that's this one right here in the middle. I want you to just kind of color it in a little bit so that you can see with whatever color. And then whatever color you're using, label that line. And I'm going to call this the pink line because I'm using pink. Okay. Now, I want you to tell me what you notice about this line. So, the origin is the y-intercept. That's what I notice. I notice that it has a slope of 1. And I also remember from my notes before that this is the parent function for a linear, for a line, a linear function. Okay, so that's what I noticed about this one. Now, we're going to talk about this as being the initial line, that parent function. Then we're going to talk about each of these and what changes from here. So the next color I'm going to grab is a blue. So I'm going to do blue line next, and I'm going to shade in this line right here, the one that's y equals x plus 4. Okay, so what I notice here is it has the same slope as the parent function. It also has moved upward, so it has moved up from the origin 1, 2, 3, 4 units. Okay, so it moved up 4 units. So from the parent function, it's the same slope, but it's just moved upward. Okay, so that's something to think about. So here, the only change from our equation was from x to x plus 4. So here, the slope stayed the same, but the k value changed, and it translated up from the origin because k was positive. It was a positive 4. Okay, so hopefully you're starting to see this pattern here. All right, up next we have the orange line. You pick whatever color you're using, and it's going to be this one right here down below. And what you'll notice here again about this one is that it has again the same slope as the original parent function, but it has been moved down 4 units. Okay, and so you'll notice here that the only change to the equation is that it's a minus 4, which makes sense because it's minus k as translated down from the origin. So we just slid it down, same slope, we've just slid it down. Okay, and then the last one we're going to do is the purple line. You choose whatever color you're using, and I'm going to color in this line right here, and you'll notice it is very different from the original. Now it does still go through the origin, so the y-intercept here is the same as the original. Okay, we're still talking about in comparison to y equals x, but then its opposite direction of slope, and it's also steeper slope than this one right here. And you'll notice that the changes that were made to it, it doesn't have any k value, just like the parent function doesn't have a k value, this one doesn't either. So no changes were made to the up and down, it stayed through the origin. The changes happened with this a value, the slope. Here we had a slope of 1, here we have a slope of -2. So the negative caused it to be going in a downward direction, flipping it, a reflection across the x-axis. The 2 made it more steep because the absolute value of -2 is a positive 2, and you'll remember that the absolute value, if it's greater than 1, is a vertical stretch. It makes it steeper, okay? And so that makes this line steeper. So hopefully this kind of one-stop shop kind of helps you a little bit be able to visualize translations. We'll go back and do that last question in just a minute.